In this unit, we're going to discuss factorial designs. Really, it's just a continuation of what we learned from the previous unit where we were examining experimental designs as a whole. One subcategory of experimental designs are factorial designs. In factorial designs, we will see both between group and within group studies be conducted. And typically with factorial designs, we're looking at treatment groups or variables that have multiple levels, or experiments where we're looking at two independent variables. So the objectives for this unit are to better understand between groups and repeated measures factorial designs. We'll spend a good bit of time looking at different articles that give us examples of these different types of experimental designs. I do want you to spend some time understanding how the different levels of a treatment are used in these designs. So again, when we talked about experimental design in our previous unit, we were talking about basic designs where we did one variable, we had a pretest, a post-test, and we compared it to control. In this unit, we're going to look at more complex experiments where we may have a treatment with 4 or 5 different levels, or multiple treatments, and so on. So again, we're going to look at some of these more complex factorial designs. When we examine the effect of independent variables on a dependent variable, we'll see that in factorial designs, we look at main effects, which is where we look at how one variable, the independent variable, affects the dependent variable. But we also can examine what are called interactive effects, where two independent variables may enhance or prevent the effect from occurring. So we'll look at interactive effects between independent variables. We'll also look at the concept of covariance, which again are other factors related to your participants potentially that can alter performance in specific types of activities. Typical covariance might be body weight, if we want to control for the person's body weight, age, and so on. But again, we'll learn what covariants are. And finally, we'll learn how to take this newfound understanding of factorial designs and use it to allow us to better understand the research that we read in our fields, in our interest area, so that we can apply that learning and that greater understanding to the problems we're trying to solve with our clients and enhance our professional practice. So factorial designs are just another example or subcategory of experimental research. Factorial designs are used extensively in our field and are typically used where we want to use or study some type of treatment or training method and look at some outcome. So if our goal is to examine 3 different training techniques, all aimed at improving endurance, performance, we would use typically a factorial design where we're going to take a group of people, have them do these 3 different treatments or training programs, and then measure some aspect of change in their performance over time. A factorial design is basically any time where we have more than 2 treatments. So experimental research, and the examples we gave in the previous unit, is where we had, one treatment and a control group and a pre and a post test. A very simple type of an experiment. That is, again, that example would have an independent variable with 2 levels and measure 1 dependent variable. In factorial designs, we have more complexity. We have independent variables that have more than 2 levels. So we could have 3 different treatments within that category. We could have 5 treatments, whatever it may be. If we're talking about some other grouping variable, like position that they play on a team, again, that could be an independent variable with multiple levels. So in soccer, we may have midfielders, forwards, defensemen, and goalies. So that would be 4 levels of the independent variable that we call position, and so on. And that's what we see in factorial designs, are more complex independent variables that have more than 2 levels. We also see in factorial designs a lot of studies where we have multiple independent variables. So maybe we're looking at soccer playing position as one independent variable with 4 levels, and then another variable such as treatment group. They all got either foam rolling or not foam rolling prior to participation. So that would be multiple independent variables, multiple factors. That's the term that we use. And then we potentially can have one dependent variable or multiple dependent variables. But factorial designs are these experiments where we have these much more complex and robust variables that we're looking at both on the independent variable side and potentially on the dependent variable side. Another thing that we're going to learn about and see on the examples in this unit is the concept of a covariate. That's an additional variable, not necessarily one that you primarily want to study, but one that you want to control for. So if I wanted to look at the performance on a 1 repetition maximum bench press in a wide range of football players, for instance, something I may want to control for is body weight, right? Because obviously people that are just heavier potentially are going to be able to lift more just because they have more muscle mass. It doesn't mean that they're stronger for their size or position. And using a covariate like weight may allow me to kind of equalize the playing field for people of all different sizes. So again, factorial designs often use this idea of a covariate to try to control for certain variables like weight or age or levels of experience and so on. So factorial designs are going to look for relationships between an independent variable on a dependent variable, just like we learned about in experimental research. But they're going to look at this in a more complex way. They're going to look for the main effects of the independent variable on the variable. But they're also going to look for interactive effects between the independent variables and how they affect the dependent variable. We see this in this interactive type effect in medications. Some medications interact with one another and can enhance the effect of one medication or depress the effect of one medication. So interactive effects are where one treatment may also enhance the effect of another treatment. So again, we'll look at that aspect as we move forward as well. Some definitions and terms that I want to discuss, and these are important, are the term factor. Okay, a factor is the term for the main treatment or main treatments if there's more than one. Factor can be interchanged typically with the term independent variable. So again, we're going to look at a couple examples here, but if my study is comparing the effects of 2 different types or 3 different types of foam rolling, one with a vibrating foam roller, one with a non-vibrating foam roller, and a control group, the factor is treatment group. Within the factor, there are 3 levels. So that is, a factor is treatment group. The levels would be non-vibrating foam roller, vibrating foam roller, and control. So the levels are the various categories within a factor. So we could have a study that examined foam rolling, 3 different types. Foam rolling would be a factor with 3 levels, and compare men and women as another factor, which would have 2 levels, men and women, to see if there's a differing effect of foam rolling on different genders depending upon the roller that's used. So again, factor can be treatment condition. It can be, again, something like how long they foam roll, or it could be a grouping variable like sport position, gender, etc. The main effect is the effect of each independent factor, independent variable on the dependent variable. So again, if I was looking at foam rollers, 3 different levels, and gender and its effects on some aspect of performance, maybe range of motion, the main effect would look at the effect of gender on range of motion and the effect of treatment group on range of motion. So the main effects look at each factor independently. The interactive effect is if I see that the gender, in this example, alters the results or the effect of the treatment. So if I found that men did not have any change in range of motion with the vibrating foam roller, but women had a huge change, that would be an interactive effect. It would say that foam rolling, specifically using a vibrating foam roller, has a different effect on men than on women. That is an interactive effect. It means one factor alters the effect of another. In a previous unit, we talked about sampling and data collection and data analysis when it comes to experimental research. And really, the sampling and data collection in Factorial Designs is conducted just as we discussed in that previous unit. The evaluation of the data, the analysis of the data, does vary in a factorial design versus kind of the more basic experimental design we discussed in the previous unit. In the previous unit, we saw, again, a pretest and a post-test, and a treatment with two levels. And typically what's used there is a t-test, the statistical test used to evaluate whether the differences are real or not. In Factorial Designs, the data analysis typically is performed utilizing an analysis of variance, or an Anova. That's the abbreviation you'll see. You've probably seen that over and over in different studies that you've read. But an Anova is a statistical test that allows us to evaluate if the differences between treatment groups is real. A t-test is used if we have two treatment groups, and Anova is used if we have 3 or more treatment groups. So it still returns the same thing. It returns a p-value that we can then compare to our preset p-value of 0.05 or whatever we chose to use. I don't want to get a lot into or very deep into the statistics, but I think it is important that you understand what these tests mean. And again, that the fact that they allow us to tell if differences in measures between groups are real, or are they potentially just due to random variability in the measures that are being utilized? So you'll see that ANOVAs are used in this type of testing. Specifically, a one-way ANOVA is used if we have one independent variable and one dependent variable. If we have an ANOVA or a study where we have 2 or more independent variables, then a factorial ANOVA is run. If we have more than one dependent variable, then a MANOVA is the test that's used, which is a multiple analysis of variance. And then if we have 2 or more independent variables and 2 or more dependent variables, then we use a factorial MANOVA. So again, I don't care that you know these differences. You're not going to be quizzed on this, but just understand that a MANOVA is used when there's more than one dependent variable, and ANOVA is used when there's one dependent variable, and then a factorial ANOVA or MANOVA is used when we have 2 or more independent variables. If we use a covariant, if we're examining or controlling for a factor like body weight, then an ANCOVA is used or a MANCOVA is used. So just don't be confused about those different terms when you see them in the literature. What they all do is basically the same thing. They produce statistically, they produce what's called an F value and then a p-value that we can compare to our preset p-value, which most often in our literature is a 0.05. So if the p-value is less than 0.05, that means differences are likely due to the treatment. If the p-value is greater than 0.05, then differences are unlikely due to the treatment, and they're probably just due to random variability. All right, we're going to stop there for this part 1 of the presentation. I really think a lot of these terms probably are confusing and hard to understand as I just talk about them. So what I want to do with the remaining portion of these presentations is actually look at examples of research studies in our field that can provide some insight as to, again, what is the difference between a between group measure, a repeated measure design, single factor, multi-factor, and so on. And I think by looking at these articles, what we'll see is examples of these different types of designs that all fall under the category of factorial design, and kind of drive home the meaning of these different types of statistical analyses that are performed within factorial designs.